Section 2.6, Library of Functions. We're going to relate linear functions to linear equations. We're going to graph and understand piecewise functions. We're also going to talk about some important functions. We still in this section might be talking about increasing and decreasing functions, relative minimums and maximums, and identifying even and odds like we did in the last section. Let m and b be real numbers. The function f of x is equal to mx plus b is called a, and I hope you guys know this one, linear function. If m is equal to 0, the function f of x is equal to b is called a constant function. If m is equal to 1 and b is equal to 0, the function f of x is equal to y is called an identity function. Write a linear function f for which f of 1 is equal to 0 and f of 2 is equal to 1. We can think of f of 1 equaling 0 to be, remember, I told you that f of x is my y. So this right here is my y. That's my y. That's my x. So I can think of it as the point x, which is 1, y, which is 0. So I can think of the point 1, 0. F of 2 is equal to 1. I can think of the point 2, 1. So if you want, just write them as those points. So we have a line that goes through 2 points. We've done this before. We have a line that goes through 2 points. Find the equation of a line that goes through 2 points. And when we did this before, we did the slope, the first thing we found. The slope, remember, is your change in y over my change in x. So y minus the y coordinate over x minus my x coordinate. So 1 over 1, which is 1. 1 minus 0 is 1, 2 minus 1 is 1, 1 over 1 is 1. So my slope is 1. So then I'm going to use y, or 1, the m, is equal to y minus x minus. I'll pick either point, it doesn't matter which one, and plug in my y and my x. I'm going to pick the first one, but you can pick either one. 1 is x, y is 0. Cross multiply, and you get x plus, or not x plus, x minus 1 is equal to y. We're talking about functions, so let's write it as a function. Instead of y, I'm going to call that f of x. So f of x is equal to x minus 1. So that's a linear function. A function which uses different formulas for different parts of its domain is called a piecewise function. Taxes are an example of piecewise function because there are different percentage rates that you pay when you get to different levels of income. So let's graph this piecewise function. The f of x is equal to 2x plus 4 if x is greater than 1. F of x is equal to 2x squared plus 2 if x is less than or equal to 1. So the first thing I'm going to do is graph this. So if I graphed it, I'm going to first draw it as a dotted line on the whole thing and then just show you what this part of the graph is. If I were going to graph it, I'd do a y-intercept of 4 and a slope of 2. Rise over run, rise over run, rise over run. Here's my slope of 2. Okay? So that's what the line would look like. But I only want it where x is greater than 1. Well, right here is where x is 1, right? So I only want it greater than, so I only want it to the right of that. So I don't want the whole line, I just want the line that's greater than 1. And it doesn't include 1, so this should be an open circle at 1. If it were greater than or equal to 1, it would be a closed circle there. If I connected the whole line, it would be 2x plus 4, no restrictions. But the domain of that part is only x is greater than 1. So now let me graph the second one. 2x squared plus 2 for x is less than or equal to 1. So I hope you know what figure that would be. That would be part of a parabola. So it's part of a parabola, okay, because it's an x squared. And if you want, you can just pick some points if you want. When x is equal to 1, if you plug it in, you get 4. So 1, 2, 3, 4. So when x is equal to 1, it's 4. When x is equal to 0, it's 2. When x is negative 1, I'm at 4 again. When x is negative 2, you have negative 2 squared is 4, times 2 is 8, plus 2 is 10. 5, 6, 7, 8, 9, 10. So I'm right there. So this looks like a parabola. And like I said, that's a closed circle, like this, something like this. Okay? So that is the piecewise function. There's my line. There's my parabola. I didn't graph the whole parabola though. I only graphed part of it. Okay? And if you want to graph the whole parabola, you can and just do the points that are relevant. Okay? Another step function could be postal rates. For the first, up to the first ounce, you put one stamp on it, one first class stamp. And these are old rates. Aren't the current rates, but same concept. You put a first class stamp on it. For anything over an ounce up to 2 ounces, you have to put extra postage on it. And then over 2 up to 3, some more extra postage and so forth. So let's say this is the postage. So if I'm anywhere between 0 ounces and 1 ounce, so anywhere in between 0 and 1 ounce, I'm at 44 cents. So let's call this 10, 20, 30, 40. So 44 cents. So I'm maybe right about here, somewhere in here. At 0, I wouldn't have anything. So I'd probably do an open circle there, but there would be a closed circle there because at 1 ounce, it's 44 cents. For anything over 1 ounce up to 2 ounces, let's say it's 61 cents. So 40, 50, 61 would be here. So it might be like 61 right there. So this would be an open circle because if it's exactly 1 ounce, it's 44 cents. If it's 1.00001 ounce, it jumps up here, up to 2 ounces. And then let's say from 2 to 3 ounces, it might be 78 cents. 30, 40, 50, 60, 78 might be right about here. And so forth. This is called a step function, and I hope you can see why. It looks like steps. So this is a step function. And it keeps going. You keep graphing it. So that is a step function. There it is right there, step function. There's also another step function, and your calculator has this step function in it. It's called the greatest integer function. And it is denoted by an x with 2 lines on each side, like double absolute value signs. Okay? Or in your calculator, I think it just says int x if you're looking for it. So this is the greatest integer function. It's less than or equal to a number. So for example, if you have 1, the greatest integer less than or equal to 1 is 1. If you have 1.2, the greatest integer less than or equal to 1.2 is 1. Okay? And think of it as, I'm like on a number line. If I have 0, 1, 2, 3, negative 1, negative 2, and so forth, negative 3. So if I have 1, the greatest integer is 1. If I have 1.2, the greatest integer still is 1. If I have 1.7, the greatest integer is still 1. Until I get up to 2. And when I get up to 2, the greatest integer is 2. Okay? If I'm at 2.2, maybe right here, it's still 2. So the greatest integer of 2.2 is 2. Okay? Think about negative numbers. If I'm at -2, it's 2. But what if I'm at somewhere right here? Look at how this was. The greatest integer, less than or equal to. Less than is to the left. So I'm going to the left. So if I'm at like 1.5, the greatest integer would be -2. This would be -2. Okay? So we could do a step function like that. If I'm at 0.9, it would be 0. If I'm at 0, I'm at 0. So at 0, I'm at 0. At anything up to 1, I'm at 0. 0.9, I'm at 0. But once I hit 1, I'm at 1. And at 1.5, I'm at 1. At 1.6, at 1.9999, I'm at 1 still until I hit 2. And then at 2, I jump up. And this is what this function looks like. Okay? If you graph it on your calculator, the problem with graphing on your calculator is you won't see the numbers included or not included. Okay? The only one way you could tell that would be if you looked in the table values and looked at the table values on your calculator. So this is also, like I said, this is a step function. It's a real function on your calculator, and you could graph greatest integer into x, and it would look like this step function, except it wouldn't have it'd just be a line. Some functions that you should know. F of x is equal to c is a constant function, okay? F of x is equal to x's identity function, and you should be able to graph these. Range, domain, you should know that this is constant from negative infinity to positive infinity. This is increasing from negative infinity to positive infinity. You should know that this is symmetrical around the y-axis, so it's an even function. This is symmetrical around the origin, so that's an odd function. Okay? X squared, you should be able to graph that parabola. You should know the domain range, where it's decreasing, where it's increasing. From negative infinity to 0, it's going down, it's decreasing, the y is getting smaller. And from when x is 0 to infinity, it's increasing. Okay? Cube function, you should be able to graph that too. Okay? And the easiest way, I'm not going to graph all of them, but when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 8. When x is -1, -1 cubed is -1. -2 cubed is -8. So you can just graph those few points, and you'll get a graph that looks similar to this. You should know how to graph the absolute value function. You should know how to graph the square root of function. And if you have trouble with a square root function when you graph stuff, here's what you should do. When x is 0, the square root of x is 0. When x is 1, the square root of 1 is 1. I'm not going to pick x is equal to 2, because if I ask you the square root of 2, I have no idea what it is. 1 point something, put it in your calculator. Or the square root of 3, but you better know the square root of 4 is 2. So you could graph these points, 0, 0, 1, 1, 2, 3, 4, 2. And you get the idea. 9, be the next one. 9, 3, okay? And you can graph that. So pick numbers you know. Just like the cube root function. I know the cube root of 0 is 0. The cube root of 1 is 1. But I have no idea what the cube root of 2, 3, 4, 5, 6, 7. But I know the cube root of 8 is 2. Cube root of -1 is -1. Cube root of -8 is -2. So you should be able to do this. Now look. -8, -2. -1, -1. 0, 0, 1, 1. You should be able to graph all that. Okay, so there's your cube root function. Reciprocal function. Again, if you need to, do it at table. If you pick 0, it's undefined. But you could pick 1, 2, 3, 4, a half, and pick numbers. So make sure you know how to graph these, and make sure you know the domain, range, where they're increasing, where they're decreasing, and if they're an even function, an odd function, or neither. This right here, even, odd, odd. Symmetry around the origin is odd. And here are some more functions you should be able to graph. 1 over x squared, the reciprocal square function. X to the 3 halves power. You can look at it as the square root of x, quantity cubed if you want. X to the 2/3 power. So you should be able to graph all these, and the greatest integer function. These are in your book, so make sure there's a page like that that looks in your book, page 234. So make sure you know these graphs.